Subscribe now and press the bell icon. Never miss an update.
Hello and welcome to UPSC IAS Brain. Today we will discuss about quantum computing. But before we start, why don't you press the like button, comment once video is over, subscribe the channel if you haven't yet. Let's get started. Threats posed by quantum computing to traditional encryption. See, today every message that we send online, every transaction that we carry out online using classical computers, it is highly encrypted. It means that the messages and the transactions being sent between two parties is highly safe and secure, and it cannot be easily intercepted by a third party. In the world of classical computers, only those who possess the encryption key, only they can access the messages and the transactions that are going on online. In classical computing, the security of messages has been ensured through various encryption techniques such as integer factorization and other mathematical models that have been developed on discrete logarithm problems. And these encryption keys cannot be cracked or predicted by any other classical computers. Why? Because the calculations involved are so complex that it might take years, decades, or even centuries for a classical computer to crack these all computational algorithms. But however, the emergence of quantum computing has directly challenged traditional encryption that is used in our classical computers. So in order to understand this, you need to know about the difference between the classical computer and the quantum computing. In our classical computer, they function in the binary format at the lowest level of computer language. Transactions are carried out in bits. Each bit either occupies 0 or as 1 a binary state at any given point of time. For example, if you take a 2-bit computer, these are the 4 different states that the computer can occupy. But binary computing does not allow these states to occupy simultaneously at any given point of time. The binary bits can be either 00 or 01, 10 or 11. So this is significantly slows down the speed of the computing with the classical computers. Even if you build supercomputers, they still carry out transactions in the binary state. And when very high levels of encryptions are followed, it becomes almost impossible for classical computers, even for supercomputers, to crack these encryption keys. As we discussed, classical computers, including supercomputers, might take years or even decades to crack these complex mathematical problems. But however, the emergence of quantum computing marks a paradigm shift in a way computing is done. As the name itself indicates, quantum computers exist in the quantum state. Instead of bits, we have simultaneously known as qubits, and they can simultaneously occupy the position of 0 and 1. So basically, quantum computing provides for the superposition of the states. Two different states can exist simultaneously, and this is the exponentially increases for computing power of the system. So this allows for parallel computing to be carried out, and thereby quantum computers have potential to crack these encryption keys that were primarily designed for classical computers. Hence, the emergence of quantum computers is seen as a threat to traditional encryptions, and this has created the need for new type of encryption that is being developed under quantum cryptography. What is this quantum cryptography, and as well as post-quantum cryptography? These are the two emerging domains in the field of quantum computing, and it is seeking to develop strong encryption techniques and methods which would make it difficult even for the quantum computers to crack those encryption keys. Currently, experts are looking at a lattice structure in order to design the encryption keys, because when lattice structure is adopted into a mathematical model, based on this, if encryption key is designed, then it might become impossible even for the quantum computers to crack the encryption keys.